Hello and welcome to our webinar on the other relationships in circle. We are basically, you need to watch this video before 417, before class on 417, and basically we're going to start with the end today, and it says draw and label a tangent to the circle. So I'm going to move this up a little bit. I'm going to use this as my tangent, so I'm going to draw a tangent. There it is. It is tangent to one point, and then it says please. It says draw a chord that has one endpoint that is tangent to where the tangent intersects the circle. So I'm going to take this chord and try to put it like that. It needs to be a little bit smaller. And so that would be our chord. And then it talks about what angle pair relationships do these angles have. Well, that's kind of what we're going to be talking about today. So here's our first one, and if a tangent and a chord intersect at a point on a circle, then the measure of each angle that is formed is half the measure of the intercepted arc. So if you look at this, the arc AB, which is the small arc, is half the measure of the angle right here, of angle 1. And likewise, arc ACB is half the measure of angle 2. So make sure you get these down in your notes, and we're going to move along. So then we have line M is tangent to the circle. What is the measure of angle 1? So we know that we just said that the angle is half the measure of the arc, and therefore we would end up with this being 75 degrees. So that's just our previous theorem. So again, now we have that if the angle, the measure of angle P, is equal to half the measure of arc PSR, that's really the theorem that we have here. And so if we know this angle is 130, it's half the measure of the arc. So if we're looking for what is the measure of RSP, that would have to be double the measure, so 130 equals 1/2 of the measure of PSR, which if I multiply by 2, 260 is the measure of arc PSR. And that's what we're trying to find out. So we're just following our theorems that we're given. So now we have to do it with a little bit of algebra, and it says BC is tangent to the circle, find the measure of the angle CBD. So we know that angle B is equal to 1/2 the measure of the arc BAD. So arc BAD. So we know angle B. So if we put in what we know, we got 5x equals 1/2 of 9x plus 20. Now, I don't know about you guys, but I don't really want to take half of 9. I mean, it really doesn't matter, but I don't really want to take half of 9. So I'm going to multiply both sides by 2 just to get rid of the half. And by multiplying by 2, then, I end up with 10x equals 9x plus 20. And so I didn't have to distribute the half and all of that stuff. That just saved me by multiplying by 2. And so now I just follow my steps of algebra, subtract 9x from both sides. And so I'm left with x equals 20 when I solve this out. So if x is equal to 20, and we have to go back and look at what the question is asking us, it's asking us to find the measure of the angle CBD. So CBD, so that's the angle, so that means that I plug in 5 times 20 will equal the measure of angle CBD, which is basically angle B, and so that is 100 degrees. So then what should be the measure of the arc out here? I know that's not the question, but what is the measure of the arc? Well, you could plug in the 20 and find it out, but if we know that the angle is half the measure of the arc, and the angle is 100, that would mean that this should be 200 out here. And we could check that real quick by doing 9 times 20 plus 20. 9 times 20 is 180 plus 20 equals 200. So we're just checking our properties to make sure that they match. So then we have another property here that basically says that if you have two chords that intersect on the interior, then the measure of each angle that is made is 1/2 the sum of the measures of the sum of the intercepted arcs. So what I'm saying is that if I take arc CD and add it to arc AB, and I want to find the measure of angle 1, I'm going to add those two together, and cut it in half, and that will be the measure of angle 1. Likewise, it works the same. If I want BC, I would add BC plus AD and cut it in half, and that will be the measure of angle 2. That's what we're trying to do. So in this problem, I don't know why that's there, but if we're finding the value of x, this is the previous theorem. It says that if we take the arc PS and add on arc QR and cut them in half, that will give us the measure of the angle, which we're going to call x in this case because it's just x in there. And so 1/2 of 106 plus 174 will equal x. So 1/2 of, I believe, that is 280 will equal x. So x has to be 140 degrees. And that's really all we're trying to do for these problems. We're just following the theorems, following the properties. Make sure you're copying them down. If not, go back, rewind it, pause it, and copy them down. So then, if we have a tangent and a secant, two tangents or two secants, basically we have the angle is outside the circle. It doesn't matter all of these, because if you look, all the properties are basically the same. You basically take the intercepted arcs, the big one minus the small one, and then cut it in half, and that'll get you the measure of the angle. So the big one minus the small one cut in half will give you the angle. Big one minus the small one cut in half will give you the angle. And that's the way all of these work. So if the angle's outside, you subtract. If the previous one, the angle's inside, you add. So now we're going to practice one where it's outside. This time, they gave us a tough one. They told us that the angle is 72 degrees. So we have to remember our property. We're going to say angle H needs to equal 1/2 the sum of arc, or the difference of arc EDG minus the bigger arc minus the smaller arc GF. And so that's our property. So now I just plug in what I know. I know this arc is 72, or this angle is 72. I plug in 1/2. I know the arc out here is 200, and GF is what I'm trying to find, so I'm going to call that x. So I'm just going to work through this problem. I'm going to multiply both sides by 2 to get rid of the division, the half. That goes away. And so if I multiply this by 2, I get 144 equals 200 minus x. It saves me from distributing the 1/2 inside the parentheses and getting 1/2 of x, which people sometimes don't like to work with. So now I end up subtracting 200 across the equal sign. And so now I have negative x equals negative 56. And if I just basically multiply or divide by -1, I'll find out that x is 56, which is the measure of the arc. So I could check it by saying 200 minus 56 cut in half should equal 72. And it does. So make sure you check those. Make sure you can check all of these problems. Again, this one looks a little challenging because now we're trying to find the angle outside. So what do? If the angle is outside, we have to subtract. Subtract the bigger arc minus the smaller arc. So in this case, angle P is going to equal 1/2 the big arc, MLN, minus the smaller arc, MN. And if I do that, I basically say, okay, I plug in what I know. I know that angle P is x. I need the half of the bigger arc, which I don't know yet, so I'm going to skip that for a minute. And this angle is this arc is 92. Well, if you notice, from this point, from point M to point N is 92 degrees. That is really part of a whole circle. How many degrees is left over here? Well, that's the whole circle is 360. So this arc is the rest of the 360 from the 92. So if I take 360 and subtract away 92, that will give me my angle that I have, and that should be 268, I believe, would be the angle that I would have there. So 268. And so now if I just go ahead and do just simplify this, I'll know what x is. So x is going to equal 1/2 of 268 minus 92. And so let's see, x equals 1/2, let's see, 92 gives me 6 there, and 17, so 176, and then half of 176 is 88, I believe. So that is the measure of the angle that I was looking for out there. I don't know why I use parentheses. It should be 88 degrees. And so if I plug this in, I should be able to just check and see if that works out. So 88, yeah, so that's what we're looking for that. And now we have this challenge problem, and it says you are on top of Mount Rainier on a clear day. You are about 2.73 miles above sea level. So you're up here at point B. Find the measure of the arc CD that represents the part of Earth that you can see. So I know how many miles above, let's see, the radius is 4,000. So, okay, so then this whole thing right here is 4,002.73 miles, and so we need to find out how big this arc is. Well, first thing we need to know is figure out how big of an arc. Let's see, they're asking us how big of the arc of CD we have there, and so we could do this a couple different ways. I'm just trying to figure out the best way to go about this. If this is 4,000 and this is 4,002, we know this is a right triangle, so this is my hypotenuse. Since it's opposite the right angle, I could find the length of CB, which I'm not sure is going to help us too much. I could use some trig, and I could find out the angle. I could find the angle down here, and then that would be half of the arc, and then we could double it. So let's do some trig. I don't know if that's the way they want me to go about it, but that's the way I see it right at the moment, so that's the way I'm going to do it. I have the hypotenuse and the adjacent to angle A, and so if I have the hypotenuse and the adjacent to angle A, I know that I could use cosine. So the cosine of angle A, which is half of really what I need, is going to be the opposite, which is, or the adjacent, which is 4,000, over the hypotenuse, which is 4,002.73. And so now I need to find my calculator, so give me just a second here. I'm sorry, everybody. There's my calculator, so I'm going to open that up. Wait for that to come open, and then we can go ahead and find the cosine of angle A. Make sure I am in degrees, which I'm not. And so now I need to find angle A, which is the half of the angle I need. And so if I basically say A is equal to the inverse cosine of 4,000 divided by 4,002.73, that should give me this arc, which is a central angle, which then I can double it and get the whole thing. So that's what I'm going to do. Inverse cosine of 4,000, the adjacent, divided by the hypotenuse. And we get, that is the measure of the half angle, so 2.12 degrees. So angle A is 2.12 degrees, and so if I double it, then the angle itself, the whole angle, arc CD, should be the double of that, which would be 4.24 degrees. And let's see how I did. Pull this out. They did it with our previous formula. But 4.2 degrees. So you could have used the previous formula. They used trig to get it. Then they used a lot harder. I'll leave that solution there. You can see how they did it with the properties that we had. All right, so here we go. We have our out as our right to learn. So go ahead and do that, and I will see you guys soon.